I'm Tim Ventura, and we're joined today by Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University. Avi is a theoretical physicist who works on astrophysics and cosmology, formerly the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. Among his many achievements, Avi is a best-selling author, has published over 700 papers and essays, made major contributions to scientific topics including black holes and gravitational microlensing, and received recognition and awards from dozens of prestigious scientific organizations and academic institutions. So, Avi, welcome, sir. It is an honor to have you back with me. It has been quite a while.
Thanks for having me.
So today we are discussing themes from your Medium article, Preliminary Anomalies of 3I Atlas. And so I want to start by asking you for an overview of what this interstellar object is and what makes it unique.
Well, so the last decade was special in astronomy because we discovered the first objects from outside the solar system near Earth. It started with the discovery of Oumuamua by a telescope in Hawaii, given the name Oumuamua because it means scout in the Hawaiian language. This was a survey telescope, Pan-STARRS, that was looking for near-Earth objects. And found this one, and it happened to be moving faster than the escape speed from the solar system. So that was the first one announced. About 100 meters in diameter, very unusual shape, most likely flat. The amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And there was no cometary evaporation from it. It was definitely not a comet of the type that we are familiar with. And nevertheless, it exhibited a non-gravitational acceleration away from the sun. And then came a very familiar object, a comet, discovered by an amateur astronomer, Gennady Borisov, in 2019, 2 years later. That one looked just like comets that we know about from the solar system, icy rocks that evaporate as they come close to the sun. And except that this one was moving very fast, therefore came from interstellar space, we expect icy rocks to be ejected from planetary systems because of passing stars. These are usually residents of the outskirts of planetary systems, the Oort cloud of the solar system going out to 100,000 times the Earth-Sun separation, where it's very cold and objects are moving really slowly there, is an example of the outskirts of a planetary system. And when a star passes through it, it can easily kick gravitationally an object from there to become unbound because these objects are very weakly bound to their parent star. And so we expect most of the interstellar objects to be comets, and indeed we found Borisov, the second announced interstellar object. And now on July 1st, 2025, half-a-meter telescope in Chile discovered a third one. Now, this one was at a distance of 4.5 Earth-Sun separation, and the fact that half-a-meter telescope discovered it means that it was extremely bright. In fact, this small telescope scooped the Rubin Observatory that was inaugurated the same month. The Rubin team looked back at the data and discovered images of this object before it was announced or discovered by the Atlas team. That's the survey telescope that found it. And actually, the Atlas telescope is very close to the Rubin Observatory in Chile. Both of them are neighbors. Now, as soon as I heard about 3I Atlas, this new object, within the same day, I was actually in the early morning hours, I was interviewed on Coast to Coast. I woke up at 2 a.m. and I learned about it from a listener to that program that emailed me and said, look, this was just discovered. And so I followed it, and within hours from the discovery, I realized this one is extremely unusual because if it's a rock, if it's an asteroid, it has to be 20 kilometers in diameter in order to reflect enough sunlight to be so bright. And the problem with that is Oumuamua is roughly 100 meters in diameter, and there should be 1 million objects like Oumuamua for one that is 20 kilometers in diameter, based on what we know about the solar system. And we haven't discovered 1 million Oumuamuas before 3I Atlas, and so that was strange. And also, if you were to take a rock that is 20 kilometers in diameter and imagine that such a rock arrives in the inner solar system every 5 years, because the survey was looking at the sky for 5 years and found this one, then the supply of interstellar rocks into the solar system exceeds by a factor of almost 10,000 the amount of rocky material available in interstellar space based on my calculations. So actually on the 4th of July, instead of enjoying the vacation that I had with my wife, I wrote a scientific paper, submitted it for publication. It was accepted for publication within a few days, basically making the point that this object, if it is natural in origin, must be much smaller than 20 kilometers, probably less than a kilometer in diameter. So 20 times smaller, 8,000 times less massive. And then to explain the brightness, one would need to assume that it's surrounded by a cloud of dust that is much bigger and reflects much more sunlight than the object itself. And so if it's a comet, then everything holds together and it would be a small nucleus of that comet. You wouldn't need as much mass. It would be completely reasonable, not very different, maybe a little bit larger, maybe a factor of 2 or 3 larger than Borisov. But we don't know that for a fact, because when people tried to measure the spectrum of this object, they didn't find any evidence for the molecular fingerprints of molecules and atoms that represent the composition of comas, a cometary tail. Instead, all they noticed is reddening of the reflected sunlight, meaning that it could be a cloud of dust, but it could also be the surface of an object that is red, because we see a lot of objects that are red in the outer solar system. And so as of now, it's not 100% clear whether this object is a comet. When you look at the images, there is fuzz around the object, and it could be a comet. The image is a little bit bigger than that of background stars that are point-like. But as it comes closer to the sun, it would become clear whether it's a comet, because if it's a comet, it will evaporate much more vigorously as it gets heated by sunlight. And but nevertheless, I was a co-author on a paper with Adam Hibberd and Adam Crowell, where we said the orbit, the trajectory of this object appears to be quite remarkable. It arrives within 5 degrees of the orbital plane of the Earth around the Sun. And the chance of that happening randomly is 0.2%. And moreover, it will arrive closest to the sun when the Earth is on the opposite side of the sun. And moreover, if you just play with the arrival time randomly, you would notice that only 1 out of 20,000 arrival times would come as close to the inner planets like Jupiter, Mars, or Venus. So that is an unusual coincidence. And why would such a trajectory be so unusual? Well, one possibility is if it was designed by some intelligent civilization, it also comes towards us from the direction of the galactic center, from the Milky Way center, where there are lots of stars, and it's very difficult to notice it. That's why we discovered it so late. By now, it's impossible for us to launch a rocket that will intercept with it, because it would move relative to Earth. It comes in the opposite direction of the motion of Earth around the sun, and the relative velocity would be 98 kilometers per second when it comes closest to the sun. And that is 3 times the maximum speed that we can accomplish with chemical rockets. And so there is no way for us to reach it, to intercept with it. and perhaps it wants to break. Like when we launch rockets and we want to accomplish a very high speed, we usually introduce a thrust near the sun, and that buys you the highest kick velocity, taking advantage of the gravitational assist by the sun. And so if this object wants to do a reverse maneuver, meaning to slow down and get bound to the sun so that if it's a spacecraft, so that they can visit us, that would be the point where we can't see it because it's hiding behind the sun. And it raises the interesting possibility that might be technological in origin. Of course, we will know much more in the coming month or two, and it may not be it may be just a comet, but I think it's important to consider the possibility that any interstellar object coming into the solar system might be technological. Because if you just consider the last century, we started transmitting radio signals, basically flagging that we exist as a technological civilization. And there is this dark forest hypothesis that is the answer to Fermi's paradox. Where is everybody? Well, they might be silent, waiting to notice things that might be a threat to them because they were bruised in interactions. So there might be a lot of aliens around. And if someone was listening to our technological signals, they might have realized that here there is a young technological civilization, and we don't want to have that threat. So they would send a hostile mission towards Earth. Of course, that may not be the case. We don't know. But it's the kind of threat that is not often entertained because, people talk about existential threats from artificial intelligence, from maybe change in the climate, or from an asteroid impact. But not much discussion is dedicated to the possibility that we might be endangered by alien tech.
Yeah. Well, Avi, whether this object is artificial or natural, the story surrounding it is incredibly interesting. And as I was doing research for the interview to prep my questions, I just became so engaged in what's going on in terms of interstellar objects. So, to frame this for the audience, to help people understand why interstellar objects may be so important, Arthur C. Clarke predicted an encounter with extraterrestrial intelligence in a passing interstellar object in the 1973 Hugo and Nebula award-winning novel Rendezvous with Rama. Now, in that novel, the Rama extraterrestrial object was discovered by a system called Spaceguard, used to track potentially hazardous objects, whereas in real life, the 3I Atlas interstellar object was detected by the Asteroid Terrestrial-impact Last Alert System, the Atlas station at Río Hurtado in Chile. So I'm wondering, could this be an example of life imitating art?
Well, that's interesting. In both cases, Arthur C. Clarke did realize that humans will be quite concerned about the possibility that rocks from the sky could cause damage. And he was envisioning an event of an asteroid impact in Italy that triggered this initiative to detect them in advance. Of course, NASA was asked by the US Congress to do so already in 2005, and that's why the Pan-STARRS telescope was established, and it discovered Oumuamua. And now we have the Rubin Observatory, which was created in order to find most of the objects that are bigger than 140 meters that may impact the Earth, near-Earth objects. And in the process of doing so, it's quite likely that it will discover of order up to 50 interstellar objects over the next decade. So we had 3 that were discovered over the past 8 years. One in 2017, another in 2019, and then the last one to 2025. But starting now with the Rubin Observatory, every few months we might have a new one. And so instead of calling them with special names, we will probably, what will happen is they will be called after the Rubin Observatory and then identified by their discovery date. And so we should just be ready for 4i, 5i, 6i, maybe 7i in 2026. Okay, there will be a lot of them. And that opens up an interesting question of whether any of these objects will be technological in origin, or all of them might be rocks, asteroids, or comets. And what Arthur C. Clarke realized is that, if we do get a visitor that is big enough, and if we can identify that indeed it's a spacecraft, it's not natural in origin, then that would change the future of humanity. And he discusses the interaction of the investigators with that object. Now, what I think we should do, I realize that there is not much being discussed, that there is no protocol for how to respond to a visitor in our backyard. It's very different from getting a radio signal from a star that is thousands of light years away, because then, we would have the leisure of waiting and thinking about how to respond, what may happen if they come here. In this case, if you have a visitor in your backyard, you have to respond immediately, and the danger may be imminent. And therefore, you might, if after October 29th, when 3i Atlas comes closest to the sun, if it doesn't emerge along the expected path on the other side of the sun, then the stock market will crash, and the geopolitical order will immediately be disrupted, because people will not feel that they are protected by their governments against the threat from the sky. Yeah. And obviously, if anyone comes to visit us from outer space, they don't care much about the way we split territories on this rock that we were born on, that we call Earth. So it would be an issue for humanity as a whole, and it requires cooperation. And the question is what to do about it. I think we should definitely establish an alert system ahead of time. We could have, for example, an array of satellites, we may call them interceptors, that are spread around the orbit of the Earth around the sun. And whenever we detect, for example, the Rubin Observatory detects an interstellar object, we identify the interceptor that will be closest to the path that it takes, and we intercept it. We can fly by and take an image of it that would definitely tell us whether it's a rock or technological object. We might even land on it. Now, the benefit from doing that, even if it's a rock and we land on it, just like the OSIRIS-REx mission landed on the asteroid Bennu, it brought back 120 grams of material from the asteroid Bennu, and we realized that this asteroid had most of the building blocks, the amino acids that are used for life. And I wonder if we find a rock from another star, whether it has the building blocks of life as we know it, or of life as we don't know it. So just finding a rock by itself would be beneficial for astrobiology. We could learn about the ingredients of life elsewhere without needing to visit those places, because these rocks made the trip to us. It takes millions to billions of years to cross the Milky Way galaxy. And instead of us going places, which would take a huge amount of time, these rocks come to us, and we should take advantage. I think it's a missed opportunity that we haven't designed an interception mission or a landing mission on an interstellar object. I think we should do that. Astrobiologists are thinking about investing more than $10 billion in the Habitable World Observatory, which is the next generation observatory in space, an expanded Hubble Space Telescope. It may take 2 decades to build it, but this is primarily for the purpose of looking for the biomarkers, the molecular fingerprints of molecules that are indicative of life, like, for example, oxygen or methane or water, in the atmospheres of exoplanets very far away. I think there should be a new approach, which is to examine materials on the surface of rocks that arrive to us from other stars. And of course, if any of these objects happens to be technological, then we can learn much more. We can perhaps reverse engineer the kind of technology being used, or learn about the science that goes beyond what we know right now, and also potentially uh, uh, decide what the intent of that visit is in case it poses a risk to Earth, because one can imagine that it's either a hostile visit or a friendly visit. If it's a friendly visit, we would welcome it with open arms, but it could also be a Trojan horse that brings a risk to Earth.
Yeah. Well, and again, going back to Clarke, just to reinforce this, in addition to Rendezvous with Rama, it is well worth mentioning that some of Arthur C. Clarke's other predictions include home computers, video calls, the internet, email, telecommuting, online banking, e-commerce, artificial intelligence, the telecommunications satellite TV, and as you mentioned earlier, spacecraft gravity assists. So he envisioned that if extraterrestrial intelligence comes to visit us, we would see it first as an interstellar object. And so that makes it well worth looking at objects like 3I Atlas.
Definitely, it's quite remarkable that he imagined all these things that we now use. He could have been wealthier than Elon Musk if these were realized by him establishing corporations that would pursue these technologies. But the other thing I wanted to mention is that he envisioned the Rama to be a cylinder 20 kilometers in diameter and 50 kilometers in length. And actually, that's very similar to the dimensions of 3I Atlas if it were to be a solid object.
Well, so the Vera Rubin Observatory, that has taken photos of this. Again, it was detected by the Terrestrial-impact Last Alert System, the ATLAS system in Chile. And so it was also imaged by the Hubble Space Telescope. I just saw images from that. And that, for me, was incredibly interesting because it shows that when we detect an interstellar object, we're at least able to bring some resources to bear on it. And for me, it's also somewhat reassuring because there's been this long-standing concern about asteroid impacts, and it looks like we have a system in place that can at least detect some of those, right?
Right. So the goal of the Rubin Observatory is to find almost all of the objects bigger than 140 meters that may impact the Earth. That was the task originally assigned to NASA by the US Congress. But beyond just accomplishing that goal, we have at our disposal follow-up observatories that can give us much more information, including the Webb telescope that detects the infrared emission by the object, not just the reflection of sunlight. And so that can help us a lot in figuring out the size of the object, the geometry of the object. By the way, 3I Atlas shows no variability. There is no change in the flux that we receive, and it could be because it's surrounded by a cloud of dust that obscures our view of this central object, or maybe it's a spherical object. We just don't know at the moment, and time will tell. Now, as a scientist, I really am looking forward to as much data as possible. The worst situation, as far as I'm concerned, is one in which the astronomers decide it's not worth observing. As was the case in Oumuamua, they thought it must be a comet or it must be an asteroid, and so it didn't get the attention that it deserved. And with this one, it looks like the community is geared up to observe it, and in fact, even amateur astronomers can use their telescopes to see it because it was discovered by a 0.5 meter telescope, and as it gets closer to the sun it will get brighter, not only because it reflects more sunlight but also because it might erupt as a comet, and then we would see the glow from the cloud of dust and gas that surrounds it. So I think we will have a lot of data about this object. And that's the fun of doing science. Whatever it is, we learn something new.
Yeah, it's so intriguing. Again, in my reading, and you've already mentioned these, but there have been 3 interstellar objects discovered entering our solar system so far. There was 1I, Oumuamua, then there was 2I, Borisov, and 3I, Atlas. The first was 2017, then 2019, then 2025. And as you've suggested, as observatories look more closely and as our detection gets better, we may begin to see more and more and more of these. And they're definitely a safety concern there because Borisov and Atlas are both being called, at least currently being called, exocomets. Moa was described as an exoasteroid. There are also things called compact objects out there, like white dwarfs, neutron stars, and even black holes that are just flying around. And so interstellar objects could be rocks and ice. It could potentially be interstellar spacecraft. It could potentially also be dangerously large objects, something the size of a planet, maybe even larger, headed our way. So
Yeah.
knowing about it helps.
Yeah, and we usually use telescopes to observe the reflection of sunlight from those objects to figure out where they are, but it may not be possible for some of them. For example, we know that most of the matter in the universe is invisible. It doesn't interact with light. It's called dark matter. We don't know what it is. It may be compact object. It may be small black holes, the mass of an asteroid, in which case such an object will come or comes already through the solar system, but we would not be able to see it with our telescopes. So today I actually submitted for publication a new paper that shows a different way of probing dark objects. You might think also that alien civilizations might build a stealth spacecraft that do not reflect much light, just like the B-2 Spirit bomber that the US military built. It's very difficult to detect it because it reflects very little light. So how can we detect those? The answer is there is no way of avoiding generating a gravitational signal because all masses produce a gravitational signal. You can't really shield that such a signal, prevent it from happening. It's a property of space-time that curves around a massive object. And so now we have gravitational wave detectors. So we calculate in this paper, the new paper that we submitted today, we calculate the signal that one expects from objects of different masses and different distances. And we find that with the next generation of gravitational wave detectors, we should be able to detect objects that make up dark matter or any other objects that pass through the solar system with a sufficient mass sufficiently near the detector. And that's a completely different approach. We might find that there are massive objects passing through that we did not know about. And that would be really important. So there is a lot to think about in terms of what may enter the solar system. Altogether, it's a very different approach in terms of searching for life elsewhere, because in the past, astronomers contemplated just using telescopes to look far away. And here we're dealing with material that comes to our backyard. So it's just like imagining objects coming from the street into your backyard. You might find many of them to be natural, like rocks, but every now and then you might find a tennis ball that was thrown by a neighbor, and obviously that will tell you that there is a neighbor out there. And that's what I'm looking for, and I think it's a new frontier for astrophysics. I think we should establish an array of interceptors that would be able to bring us samples of material, or at the very least take close-in photos of the objects by flying close to them. And then we may discover things that we've never imagined, except perhaps for the kind of things that Arthur C. Clarke already imagined.
Yeah, it is so amazing what is out there waiting for us in space. Now, I don't have the exact number in front of me, but the Oort cloud alone, I've read, contains thousands to potentially millions of undiscovered objects. Like you said, they're not really reflecting light, right? Now, I probably got that number wrong. I could see from your face.
It depends on no, there are many more because small objects are impossible for us to detect. They are very faint. They don't reflect much sunlight. So it really, there are probably a quadrillion of small objects. The size approximately of a person out there. These are icy objects that we can't really see. And in fact, even a giant spacecraft, that is the size of Rama that Arthur C. Clarke imagined, it cannot be observed at distances that are greater than maybe 10 times the Earth-Sun separation. It will be just too faint. It doesn't reflect much sunlight. And so you can imagine another civilization parking in the outskirts of the solar system and waiting to notice any signals that indicate that we passed a certain technological threshold. And it would have taken 3I Atlas 8,000 years to arrive at Earth from 100,000 times the Earth-Sun separation, the outer boundary of the Oort cloud. If, on the other hand, it was parked, let's say, at 100 Earth-Sun separations, then it would have taken it only 8 years. And so if there are probes waiting for us to show signs that we are maturing technologically to the point where they might be worried about us, they could easily send a reconnaissance mission to do something. And we should be aware of that risk. We just didn't think about it before. And I think it's a security risk that we must contemplate. And at the very least, we will learn about rocks from other stars, but we might learn much more.
Yeah, I just saw a news story about a new planet they believe they've discovered, something out past the orbit of Pluto. And I believe that was discovered, if I remember correctly, Pluto itself was discovered by gravitational interactions with other bodies, right? So,
Right. Yeah, but in this case, they noticed the reflection of sunlight from a new object. Now, when they say a new object, you don't know that it's a rock. Now, what would be the signatures of a technological object? Well, one of the signatures would be non-gravitational propulsion, some engine that moves it around. For that, you need to monitor the object and see that it deviates from the orbit you expect based on gravity alone. Another aspect is the shape of the object. If it looks unusual, in the case of Oumuamua, it seemed to be flat, which is quite unusual. Another is if you can take a spectrum, you might notice that the composition of the object is unusual. And of course, if we can fly by, which is not the case very far away, but closer to Earth, we might design a mission that will rendezvous with the object. In that case, we can take an image and see what it does. And also, of course, if the object is a mothership that sends mini probes towards the inner planets, that would be indicative that it was technological. And we can notice that by realizing that after the passage, there are objects around the Earth, in the Earth's atmosphere, that are functioning technologically that were not there before. And they behave in ways that we cannot fully understand. And that's, of course, the objective of the Galileo project. And just a brief update, we are now assembling 2 new observatories, one in Pennsylvania, another one in Nevada, and they will be hopefully using multiple units that allow us to triangulate, to see an object in the sky from different directions so that we can infer its distance, its velocity, its acceleration. And altogether, it would allow us to identify any anomalous objects that cannot be categorized as human-made or natural using the machine learning software that we developed.
So things are moving forward well with the Galileo project. I did want to ask about that because, you were looking for things in the air here, right around us, instead of necessarily just in deep space. And so people need to be aware that, extraterrestrial intelligence may be found in a variety of places. It may be right under our nose, right? We have decades of anecdotal evidence saying that. So it is worth investigating.
Definitely. And I take the scientific approach, which is not to rely on the stories that people tell me, but instead to collect data by state-of-the-art instruments and analyze the data with machine learning software that knows how to recognize familiar objects. So we are looking for outliers, things that do not line up with our past knowledge. And gladly, we received funding from donors to do
Oh,
this
good.
work. And I cannot tell you all the details, but it would be really exciting. We are expecting data on a few million objects every year. And that will be the biggest data set that was ever collected about objects near Earth. And if we find anything unusual, anything to do with humans, satellites, airplanes, drones, balloons, all of these things are boring as far as I'm concerned. But if we do see something behaving in a crazy way that is not explainable as a human-made object or a natural object like a bird, we will definitely analyze the data carefully and report about it.
Yeah, it's amazing how much change is going on technologically. So I just did another story on satellites. Currently, there are around 15,000 satellites, roughly 15,000 satellites in orbit around the Earth. And that number, depending on who you listen to, could go from 30,000 up to maybe 100,000 satellites in the next decade.
Yeah.
And so the sky is getting more and more crowded. And of course, there's always the possibility that not all of those satellites are human made. But the other thing that intrigued me was, as a part of this project, I guess, monitoring these, as well as for defense purposes, the new Golden Dome initiative is looking at doing spaceborne radar. And so the thought occurred to me, I was like, I wonder if the Galileo project at some point might be able to tap into that radar and get an even better view of what is flying around in the Earth space.
Well, I'm sure this data would be classified, but I see it the other way, and I briefed Congress on the 1st of May, 2025, and I basically said, if we don't find anything beyond this Earth, we don't see any extraterrestrial technological artifacts in the Galileo project data, I would still be satisfied because everything we do, the software we develop, the kind of instruments we develop, can be helpful for the Department of Defense that needs to identify objects in the sky, especially if they are launched by adversarial nations. It would help the defense of the nation if they get access to state-of-the-art algorithms and sensors that we use. And therefore, it will not be wasted. The ability to identify objects in the Earth's atmosphere is really important for national security. And you might say, okay, well, the Department of Defense already invested many billions of dollars in sensors, but it's not just the sensors, it's the way you analyze the data, the way you filter it, the way you identify objects. And now with artificial intelligence, we might have new tools that did not exist in previous years. And moreover, as a scientific project, the Galileo project attracts a pool of talent that may not be working at the Department of Defense right now. So, just think about the Manhattan Project, where the best scientists were involved in an initiative to develop something that didn't exist before, and obviously they were needed. You couldn't just take people from within the government to do that job. And so my hope is that we will be useful no matter what. But personally, what I would like to find out is, are we alone? And is there anything out there? And, so my personal belief is that we need to invest in the search. And right now, the astrobiology community is very eager to detect microbes, either in the solar system or beyond in near other stars. I find microbes boring. I really think that we might not be alone, because I don't see us as special and unique. And without searching, we wouldn't find anything. And the thing is, we have the technology and the expertise to actually search for things like us, for other civilizations that produced equipment that goes to space of the type that we launched. And that would be very interesting to search for. I mean, if we don't find anything, then we can argue perhaps there might not be anyone there, but we haven't done the search. Only over the past decade, we found the first interstellar objects. And just in January 2nd, 2025, there was a near-Earth object that was classified by the Minor Planet Center as a rock, as an asteroid, near-Earth asteroid, that later, within a day, they realized, oh, that one actually went along the path of the Tesla Roadster car that was launched by SpaceX. And so it was not a rock, it was a car. And I'm just saying that Elon Musk may not be the most accomplished space entrepreneur since the Big Bang. There might be other cars floating in interstellar space and even things beyond the car. So we should be open-minded and just look for data, for evidence to guide us. And that's the way science is done. That's the way we learn new things. My current challenge is to convince the rest of the scientific community that this belongs to the mainstream, that this should be funded at the level of billions of dollars rather than the search for microbes, because there is a lot of interest in the public. So when scholars argue, we should not take risks, this might be an extraordinary claim to imagine intelligence out there, because we don't want to waste the taxpayers' money. I say, well, let's ask the taxpayers what they want their money to be spent on. I don't think they would favor spending it on just the search for microbes rather than the search for intelligent life or the search for the nature of dark matter. As much as this is interesting academically, it resonates less with the general public.
Yeah, no, absolutely. Well, and one of my takeaways from all of the research that I've done and from everything that you've said is 3I Atlas, it is not the first interstellar object we've seen. It will not be the last one. And in fact, the pace of discovery is picking up there. And again, as Arthur C. Clarke predicted, if one of these is some kind of a spacecraft coming into our solar system, we would see it as an interstellar object. That's how we'd pick it up.
Right.
So we need to pay close attention to those, because maybe it's just a ball of rock and ice this time, but the next one may not be.
Yeah, and also, we should get out of the mindset of the Stone Age, where everything in the sky is made of stone or rocks, without allowing the possibility for an extraterrestrial technology, we would never find it. Of course, there is a lot of pushback from experts on comets, because they base their assertions on past knowledge. And whenever you are confronted with anomalies, there is a very well psychological effect called cognitive dissonance, where an expert is getting upset when data does not line up with expectations. And very often anomalies are shoved under the carpet of traditional thinking for that reason. And innovation is suppressed in science. So my hope is that we will approach this subject with an open mind, without our ego involved, without prejudice involved. And as long as we collect data, we might find things that surprise us.
Wonderful. Well, Avi, thank you so much again for your time today. Again, it is always a pleasure and truly an honor to be able to speak with you again. I love being able to discuss interstellar objects with you. And I want to close by, of course, asking people to visit the Galileo Project online, read your Medium blog, and I'm going to put links into both of those. And I also want to ask, what is coming up for you as we move deeper into 2025?
Yeah, so first we have the new Galileo observatories that I'm actually involved. I'm in the trenches helping our engineers put them together. I actually got bruised in one of the recent visits. And also we had, as you may remember, an expedition to the Pacific Ocean to retrieve materials from an interstellar meteor that was identified by US government satellites. We hope to go again, and there is another meteor that might be interstellar, and we just need funding for that. at the level of a few $1 million. So we are waiting for a potential donor for that. And there will be a Netflix documentary coming out at the beginning of 2026. And it should be quite interesting because they followed me over the past few years. And in fact, I was asked by the director of that documentary whether I changed my behavior because they are always following me anywhere I go. And I said, no, no way. Don't think so highly about yourself. As far as I'm concerned, you are just a fly on the wall.
Yeah. Well, on that note, let me thank you again so much for your time today, sir.
Thank you for having me.